all of them. Okay. Starting with number 3. Final factors for x squared minus 5 and x plus 2. Okay, as soon as I finish the grouping, remind me again, and I'll let it go. Number 5 for grouping, final factors 3y plus z and 2y minus 1. The grouping. Yep. Questions on either of those two? Five. And then the last one in grouping was 12. X squared plus 2 and y squared minus 3. Aubrey, and which does math? Is this the mixed factoring or specific factoring? No, mixed. Okay. Why? My internet is out right now, so I can't pull it up. But if you tell me what the question was, I can probably work it out. It was 10 to the 11 minus 18 to the 7. So it was in 2 and 7, and then. Sorry, I didn't. That's what you just said. It was 18 and 7 pounds. To the second power. It was still 18 to the second? Yeah. Okay. And then 1 to the end, and then minus 72. Yeah. Okay. And it's just asking you to factor it? Yeah. So this has 4 terms, so this would be a grouping, factor by grouping. So what could we divide out of these two? This is everyone's question. 2 and how many n's? 2n squared.
Numbers when y n with only one x go to n.
Yeah. So like this one, I couldn't say this is 3 because this one doesn't have 3.
Yeah. And you said that 2 wouldn't go with 1.
Right. So same thing here. I couldn't. The exponents are different. But like I can't say this has an n in common because they don't. But if it had this, they only have 1 n in common because this one doesn't have 2. We divide out 2n squared, what's left? Minus 9. What do the last two have in common? Yeah, I was saying just a number, and I think it is 8. We divide out 8, what's left? N. 9. So then our factors, we have 2n squared plus 8 and 5n minus 9. Did that help, Aubrey?
I know that already 5n and it wouldn't
my internet was working, I'd be able to see what was wrong with it. It may be a spacing issue. But I'd have to look back at it. If that still doesn't work, later let me know. And once my internet starts working, I will look back at that.
How do you know where to find the range?
You're always splitting it in half. So you need two terms and two terms, but the sign in front of the third goes with the second set of terms.
What if there was an E sign in one number?
Grouping only works with four terms. What did it say?
Same exact thing.
But it said it was wrong.
Yeah.
Let me look at it. Oh, yeah, because you can factor the 2 and the 8 again. I completely disregarded that. That would be your final answer. Because it wants you to factor it completely. I missed that. Because this one's not prime. And then that should work. So if you get another one like that, just look for if your final factor is if both are prime. If one's not prime, you have to factor something else out. Rest of the practice problems. Number 1, there's a lot going on here, so I'm just going to read the final factors. So number 1 was x minus 5 or x plus 1. Number 2 was 2k plus 1, 3k plus 2. Questions on either of those? And then number 7, again, there's a lot going on, so I'm going to just point out the final answers. Number 7, 2a minus 1, 2a minus 1. Or you can rewrite that, since they're both the same, as 2a minus 1 squared. 8 final factors, x plus 9 and 2x minus 1. Questions on those two? And then the last 3, number 13, 3y minus 2, 5y plus 4. 14, 2 times 4x minus 1 and 4x minus 1, or you can rewrite that as 2 times 4x minus 1 squared. 15 was 3 times 2m plus 1, 2m minus 5. Questions on those 3?
What's number 8?
Number 1. I didn't go over that one, but I can show you that. 9 was 2x plus 3, 3x minus 4. Some of you may have started the quick math, some of you may have not, but okay. I am still going to go over these, that way you have them, you look back at them, still practice it. Number 1 was a GCF problem. These each have 3xy in common. So if you divide out 3xy, you'd be left with x squared minus 2xy minus 3. We could not factor trinomials because we have 2 different variables, and we're only doing 1 variable. So that would be your final answer.
How do you alter the number?
Number 2, you have difference of squares. Because 9, x squared, and 16 are all perfect squares, and you're subtracting. So you'd end up with 2 factors, 3x minus 4 and 3x plus 4. All of these are perfect square terms. So because of that, you can find what times what gives you 9, what times what gives you x squared, and what times what gives you 16. And then put a plus and minus. Number 3 was a trinomial where the GCF is 1, so we can't factor anything out. So we have something in front of x squared that is not 1. So we have to do what we did last class. Multiply 4 and 6 to get 24. And we're looking for 2 numbers that multiply to be 24 but add to be negative 11. That would be negative 8 and negative 3. Rewrite it into 4 terms. Find the GCF, which is 4x, leaving x minus 2. And then find the second GCF, negative 3, which is x minus 2. And our final factors will be 4x minus 3 and x minus 2. Number, yes.
So just put a equals 1.
That's the type of trinomial you have. So this one, the number in front of x squared is your a value. That one does not equal 1, so this is the method you would have to use. And since this one, there is a 1 there, the method is shorter. Now you could do this method for this one, it would just be a longer process. Number 4, you're looking for 2 numbers that multiply to be negative 54, but add to be negative 3. And that would be negative 9 and 6. And you could put those directly in your factors. Number 5 is something we're going to talk about in the next unit, but to show you what it is. It's asking for the factors, and what you would do is look for your roots or your solutions or your x-intercepts. And whatever it says, you would write the opposite sign. So if it says minus 5, you put plus 5. If it says 2, you put minus 2. And those would be the factors of this.
Does it matter if it's ordered?
It does not. As long as the plus 5 and the minus 2 is there. Either on the back of this sheet or somewhere where you have space, I want you to write these 4 problems. This is the last thing with factoring we need to talk about. Who's still writing these down? Oh, they're not on your paper. Write them down somewhere where you have space, or on the back of the quick text. So we're going to do 2 of these, and I'm going to leave 2 of them for you to do later. They look complex because of the fractions. We are going to make it so it's not that complex. We're going to start with this first one. So if you get something like this, so right now we have a trinomial where the a value is 1. Trying to figure out what times what would give us 1/9, but add the 2/3, that would be way too complex. So what we're going to do instead is get rid of the fractions. Focus on the last fraction. If I multiplied that by 9, it would give me a whole number. So I'm going to multiply the entire thing by 9. And this is going to change it to 9x squared. 9 times 2/3, that'd be 18 over 3, 6x. And 9 times 1/9 would give us 1. Now it looks like something easier that we can work with.
You only multiply it to the top.
Yes. This is really over 1. You're multiplying 9 times 2 and 1 times 3 and then simplifying it. Now we can go into our, we're looking for 2 numbers that multiply to be 9 but add to be 6.
Wait, what is that? You did the last one, and 9?
Yeah, because if I multiplied everything by 3, this would still be a fraction.
Wait, so you take the second one and multiply it?
Yes. Yes. No, we're not going to multiply it by the reciprocal. We're only going to multiply by the denominator of whatever this is. Because for this one, and you'll see this in a second, I'm not going to multiply everything by 36 over 49. That would make way too complex.
Because it's
3, yes. So then we could rewrite this. 9x squared plus 3x plus 3x plus 1. What did the first 2 have in common?
3x.
3x. What would be left?
3x.
And what can we divide out of the last 2?
1.
Leaving 3x plus 1. What would our final factors be?
3x plus 1. 3x plus 1.
Since there are 2 of the same thing, you can write it as 3x plus 1 squared. Don't have to, either of these is fine. What you'll notice with these type of problems, you'll see the same factor twice. Do you have any questions on this process before we do the next one? So for this one, the one that's going to show you, we're going to multiply everything by the denominator, so 36. So we would end up with 36w squared. I know 36 divided by 3 is 12. 12 times negative 7 is what?
Negative 84.
Negative 84. You can either multiply and then divide or divide and then multiply. But you should get negative 84 w here. And then when I multiply 36 to 49 over 36, I get just 49. I don't believe this has a DCF, but we can check it. Let's see. Factors of 49, 1, 7, 49. No. So it doesn't have a DCF. What is 36 times 49?
1,704.
1,700.
Basically.
So we're looking for two numbers that multiply to be that, but add to be negative 84. Let's start finding factors. 1 and 1764. It's even, so 2 and 3 and, is it divisible by
42.
42 and what?
42 times 42.
If you find it quickly, that's fine. You can start guessing, you can still go in order, it really doesn't matter. But whatever works. But these would both need to be negative. So we have 36 w squared minus 42 w minus 42 w plus 49. As you start doing this, you'll notice that the middle two are usually going to be the same numbers. What do these first two have in common?
W.
W and 6, yeah. Leaving 6W 7 minus 7. And then what did the last two have in common? Negative 7. Which would leave us with 6W minus 7. So our final factors.
6W minus 7.
Or you can write it out as 6W minus 7, 6W minus 7. Questions on that one? So later when you have time to practice, you'll be doing those last two. You're now going to switch gears. I'm going to leave these problems right here for if you want to practice some more factoring later. And I don't think the pages are in order. Find this page. Now we're going to be dividing polynomials. Some of that will be using factoring, some of it won't. With these, there are two different ways to go about it. I'm going to show you both. One is to take each term and to separate this fraction. What I mean by that is, instead of everything being over 4, rewrite it as 8t over 4 plus 12 over 4. That way you're dividing each piece by the denominator. And then simplify. 8t over 4 would give us 2t. And 12 over 4
3.
Just 3. There's nothing else I can do with that, so that's as simplified as possible.
What happened to the teeth? Oh, wait, no.
The other way you could do this is see what these two have in common. What do 8t and 12 have in common? 4. If we factor out our 4, what's left?
2t plus 3.
That is 2t and then plus 3. If you factor out what they have in common, then you can just divide those two and you're left with just 2t plus 3. So both ways work. Sometimes when you do the factoring method, you have remainders though. So that gets not complex, but you have to leave whatever it is. I don't know if there's examples on this, but I can make up one. Let's do, and then moving forward you can choose, do you want to do the factoring method or the dividing method? I'll do both for this one, but then moving forward I'll just do one. So if we're doing the dividing method, we would write these both over t. Now our exponent rules are coming back into play. If we're dividing like bases, what are we doing with the exponents? Subtracting. So 2t squared over t would give us, and negative 9t over t, negative 9. If we were to factor out what these have in common, what do these have in common? 1 and something else. T. We divide out a t, what's left? If I'm dividing everything by t, those t's cancel, just leaving 2t minus 9. I'm just going to use the factoring method, but if you want to keep using the dividing method, that's fine. For number, yes, honey.
Why do you not keep the that?
Because we're subtracting the exponents. We did 2 minus 1 to get 1. Let's do number 3. What does this have in common?
5.
5 and t. We divide that out with left.
3.
3t plus 4 over 5t. We have 5t over 5t. Those will both cancel, leaving just 3t plus 4. Questions on this so far? Let's jump to number 5. What does this have in common? AB. What would be left?
8.
8a plus 3b. If we're dividing everything by AB, those would cancel, leaving just 8a plus 3b.
Equal.
Or higher.
Okay.
We're gonna do number 6 and then do one of the bottoms and then move on to the other page. Number 6, what does the top have in common?
2.
2 and
P.
T. Which will leave us with
2. 5.
is minus 5. The 2 t's would cancel, leaving 2t squared plus 9t minus 5. Now, in this case, we could possibly see if we could factor it, but it's not asking us to do that. 2 times negative 5 would be negative 10. Negative 10 that adds to 9 would be 10 and negative 1. So we could factor it, but it's not asking us to do that, so we don't need to do that for this one. So know when to stop. Now, if the problem did say, what are the final factors, that would be different. Let's do 8. What does 8 have in common? 9. 9 A. 8. Yes. If we divide out each of those by 9 to the third B, what's left?
2A4, B4.
Plus
5A2,
A squared B squared and
plus A plus 1.
plus just 1, yes. All of those will cancel, leaving just 2A to the 4th, B to the 4th, plus 5A squared, B squared, plus 1. Oh, I know. How do we feel about dividing polynomials by a monomial by a single term? Good, thumbs up, okay, sideways, down, not good. Okay. Now we're going to take that concept and do a little bit more with it.
Yes. So for negative 9t, why isn't it plus negative 9 at the top being divided?
Here, why isn't this plus? Because it was already negative. So we wouldn't change it. If we took out a negative, then it would change.
Can you just say maybe reach out and not rely on the denominator?
If it's a monomial, so one single term, then you can. Yes. But we're going to do some that aren't just one term.
So what would happen if we had to do
Like 0 in the final answer.
Yeah,
Do you have an example of that?
yeah.
Which one? I'll write it down.
And go on the next page.
My pages are not very much. Which one are you talking about?
We need to buy polynomials by polynomials.
Oh, this one.
That's not one here. Which number is it?
No, what?
Got it. We're gonna do this, and you're not gonna get 0. So that's why I was just saying, what we were doing before is different than what we do with this. So if you get a polynomial divided by a binomial, you have to factor it. So you'll have a trinomial that either has a equals 1 or a does not equal 1. So with this one, we have a equals 1. So we're looking for two numbers that multiply to be 6 and add to be 5. What would those two numbers be?
3 and 2.
Remember, if your a is 1, you can go straight into your factors. You have x plus 3 and x plus 2 all over your divisor x plus 3. Yeah, then after you factor your numerator, you can pretend this has parentheses if that helps you to see this better. But you're looking for like factors, and you're going to cancel those out, divide those together to leave you with just one answer. So you shouldn't get 0 in these cases. I will go back to that number 6 and do that here in a second. Before we continue, do we have any questions on that?
I don't do the greatest factor.
In this case, because it's a trinomial, the GCF here is 1. So there wouldn't be something we could factor out. Let's do number 2, and then we'll do a couple of minutes. For number 2, we're looking for two numbers that multiply to be 27 and add to be 12. 9 and 3. When you look at your denominator, that kind of tells you what one of the factors is going to be. So that kind of helps you. So this has a equals 1, so you can go directly into your factors. X plus 9, x plus 3. So what would your final answer be? X plus 3.
Are we always going to be like that? Or are we
Factors.
top number is going to be equal to the denominator?
Yes. If it's polynomial over a binomial, then yes. Let's see number 4. Now we have something where a is not 1, so it's going to be a little bit more to it. This does not have a GCF. We need to multiply 6 and 5. And we're looking for two numbers that multiply to be 30, but add to be 13.
10 and 3.
10 and 3. Because this is one where a is not 1, we have to go through all of the steps, so we can't just put them into our factors. So rewrite it as 4 terms, 6x squared plus 10x plus 3x plus 5. Or if you want to switch those inside, you can. Michael.
Why do we have to sometimes just write number or multiply both of these on the side?
It depends on what it looks like. So if there's no number in front of us, we can just look at this and this. But if there is something in front of this, then we have to do all those steps.
No.
What did the first two have in common? 2x, which would leave us with 3x plus 5. What can we divide out of the last two? 1. Which would leave us with 3x plus 5. So we have two factors. All over 2x plus 1. So even when you do all of those, you still have to remember you're dividing, and something is going to cancel. Okay. So what would our final answer be? 3x plus 1. I don't have these on here, but I'm going to pull a couple of the ones from the dividing polynomials by a binomial page. Starting with number 3, and I'm going to do number 6 also. This is on this page. I just don't have this page on this. We're still going to do the same thing, factor the numerator and look for like factors. How would we factor this numerator?
We would
Or no?
y plus 5 and then y minus 5.
Yeah, so your difference of squares would be the method. So what would your final answer be? Y minus 5.
Are you like dividing each like y? Why she divided by y?
Think about it like this. All of this is one thing, and I'm dividing these together. Just like when we were dividing the individual pieces, if I had 2t over t, the t's cancel. Think about this like one part, one thing together.
Why she divided by y? Is it 25 divided by y? Why she divided by y?
That happens to work, but not in all cases. So I wouldn't think about it like that. For 6, how could we factor the numerator? We could take out a 5. If there are 2 terms, it's only one of 2 choices, GCF or difference of squares. It's not squared, so it's not difference of squares, but we can factor out a 5, which would leave us with now this is different than kind of what we were doing before because the factors have changed, but we still have like factors we can cancel, so our final answer would just be 5.
So for number 6, you always just divide by the first number.
It depends. Here we only divided by these because they were like factors. So look for things that are the same. If we ended up dividing something out and these weren't the same, then that would happen. I'm going to do number 15 on the back of that page. It's written horizontally. I'm just going to rewrite it so it's vertical. How would we factor this numerator? With all of them. Okay, so one would be the GCF of all of them, but if we have 4 terms, what type of factoring can we do? Looping. Right. So with all of these, you have to be able to recognize what type of factoring are you using. So what could we divide out of the first two?
X
Squared, leading.
X minus y.
And then what could we divide out of the second two?
Negative 6. 6.
Leaving.
Negative x and y.
So we switch. Since we took out that negative, x minus y.
Why would it be minus?
Because we're divided, we already took out the negative. So it'd be negative, it'd be 6y divided by negative 6, which would give us negative y. So our factors would be x squared minus 6 and x minus y over x minus y. What would our final answer be? X squared minus 6. Go to the page that says Untitled Chapter. So with this one, I'm going to show you the Desmos trick again on how you could find the correct answers without really doing the work. Now on the test, you will have to do the work, but on the SOL, they're not going to do
So will we have a calculator or will we have?
it. They'll only have this. I don't know if this will work. I may need to restart my computer. So it's connecting. Well, I can talk you through it without me showing it. And then if you want to try this on your own computer, you can pull it up and try it as I'm talking you through it. So for the first one, you would put that entire function in Desmos, 16x squared plus 40x plus 25, in one of the lines. Then you would put each of the answer choices in another line. And you'd be looking for two things. One of those lines has to cross, so the function you put in there is a quadratic, it looks like a U shape. One of the lines you put in there is going to cross that U shape along the x-axis. So it has to cross along the x-axis at a specific point, at one of the intercepts of the quadratic. I'm trying to remember everything about this and explain it visually. So somewhere along the U there would be two x-intercepts. The line would have to cross through that x-intercept on the x-axis. If it crosses through the U shape but not at that point, it would not be a factor. Or if it crossed through the x-axis but not on the x-intercept, it would not be a factor. Same thing with 2. With 3, it's written backwards. The numerator is written backwards, but you could still, if you were to do the work, factor that out and then find which one would cancel. Or if you put that function in, you would end up with one line, and then you could put in each of the answer choices to see which line matches. Anytime you have a problem like this, if it gives you something that's squared and it's already being squared, that's not going to be an answer. Because if I have something that's squared and I'm taking something out, it's not still going to be squared. So it would have to be A or B, and then you would just figure out which one matches. I do want you to practice some of these. This, yes. So starting with the 2 problems you wrote on the back of your quick check or wherever you had space, you're going to do these 2. Along with, mine did not have all of these problems, or I would have just done 6 and 7 on this page. Anyway, on the polynomial division page, one of these is I don't have all of these, but number 3. Your number 3 is different. Yeah. Okay, that's fine. Six and 7. So 3, 6, and 7 on the polynomial division page. That starts like this.
3, 6, and 7.
3, 6, and 7. On the more polynomial division practice, numbers 4 and 7. And that's it. So the 2 from the quick check page, numbers, I already forgot what I just said.
Numbers 3, 6, and 7.
3, 6, and 7, and then 4 and 7. And then we'll go over that towards the end of class. This one was 3x minus 2 squared. The other one was 4y plus 1 squared.
How many divided?
As soon as we finish going over this, though. Questions on either of those? For the polynomial division, number 3, you can factor out a 2 as a GCF. Then your A becomes 1. So you're looking for two numbers that multiply to be 1, but add to be -2, which would be -1 and -1. Only one of those factors would cancel, not both. So you'd have 2 times x minus 1, or you could distribute that and get 2x minus 2. Number 6 was a grouping one. So you had m squared plus n, 4m minus 1. The m squared plus n canceled, leaving 4m minus 1. And then number 7, the factors would be m plus 3, m minus 3, m plus 3 would cancel, leaving just m minus 3. Number 4, you could factor out a t squared, leaving 16 minus 11. 7 was a little weird because it had a GCF, but when you tried to factor out the GCF, you ended up with weird denominators. Instead of doing that, you could divide them separately. There is a way to do it with the dividers, and I'll show you that if someone reminds me on next week, because I won't be here on Friday.